Hello everyone, this is Levi Sheridan, and today I'm making a video about my 3D printed Bistable compliant Flexure tool mechanism. I was inspired to make this Flexure by a channel called Design Prototype Test on YouTube. The gentleman who runs this channel designed his own Flexure to hold a broom, and I was inspired by his design to make a Flexure to hold my tools. I watched his videos a few times and took the information and knowledge he shared to inform my own design, and I'm really happy with how it turned out. The way this tool holder works is simply by removing the tools. The flexures reset themselves, and when you are done, you can simply re-enter the tool and the flexures hold on really well. I will remove one of the flexures so I can talk about it in isolation a little bit more, about its design and how I made it. It is made up of two different materials and two different parts. There's the white part, which is a flexible rubber-like material called Ninja Flex, and it has two positions, two stable positions, meaning it's bistable. This is one position, and there's the other position, the in and out position. There's the blue part, which is a rigid plastic piece made out of PLA, and that is what holds the flexure mechanism together. The way in which I built this is really cool, I think. This plastic, or the rubber piece rather, is encapsulated within the blue plastic piece, meaning they're permanently attached. And I'll put up a video on the screen of what exactly I'm talking about and how I made this, but essentially these two parts are permanently attached together. There's no way for them to come apart at this point, and it's a really well put together, professional looking flexure, I think. And when it's integrated with the stand, I think it looks really great, and obviously it works really well. It is very consistent, and I think in general it has a lot of applications apart from the stand. I've tested it with other things like chopsticks and wires for charging devices and data transfer and other things of the sort, and it works really well. So I think maybe a few other applications could be found for this, maybe a little flexure to hold onto your phone cable next to your bed, or you could attach these to a pegboard and use them in that case. But this is my application of my flexure, and I really like how it works. It's works really well. It's consistent, it looks nice, and it's just a nice, satisfying little flexure I have designed. So that's pretty much it. It's my 3D printed flexure, bistable compliant mechanism. I was inspired by Design Prototype Test. Like I said earlier, I'd like to thank him for all of his work and him sharing his knowledge on his way of designing and building flexures. I'm not sure how long this would have taken me if I didn't have his knowledge, but I think this was my third prototype. It took me a few hours to get to this point, and it works really well. So once again, thank you to the gentleman who runs that channel. This is Levi Sheridan. I hope you found this interesting, possibly learned something new, and I hope you have a great day.